So I believe that you would have taken down this question number 5 and you have understood how to solve such questions. Let's go to the next question of the class, question number 6. Question number 6, an ideal gas is expanding such that Pt to the power 2 equals to constant. The coefficient of volume expansion of the gas is A 1 by T, B 2 by T, C 3 by T and D 4 by T. So given the 4 options, we need to choose which option suits with the best one and we need to find out the coefficient of volume expansion. See, in the first thing, what is coefficient of volume expansion? You must have known in the chapter on expansion that volume expansion is given in this way, dV is equal to V gamma and let me put here dt. A small change in volume is equal to V gamma dt, where gamma is the coefficient of volume expansion. This is what we have learnt in our regular session. Gamma is the coefficient of volume expansion. Next thing you see, gamma can be written as gamma is equal to dV by V dt. This is what we are obtaining for the value of gamma. So in any ways, if we have a relation in this way, we can evaluate the value of gamma. Given in the question, it's Pt to the power 2 equals to constant. That means pressure into temperature to the power 2 equals to constant. Let's go ahead. Let me write down Pt to the power 2 is equal to constant. Let's keep this constant as K. Now we know that PV equals to nRT. So PV is equal to nRT. So clearly from here you can put the value of P as nRT by V. This is what you can do. You can put the value of Ps equal to nRT by V. Next thing you see, you can put here, substitute the value of pressure in terms of volume. So you'll be obtaining nRT by V and multiply by T square. You will get this as a constant. This is what you can say. Now next thing you see, here you have T cube and here you have V power minus 1. nR and a new constant. So can we replace this equation as T to the power 3 into V to the power minus 1, that is constant. So we can replace this as V to the power minus 1 into T to the power 3, this is equal to constant K. See, because N and R will be constant for the system, N and R will be constant. So you can take T to the power 3 into V to the power minus 1. You got a relation between temperature and volume. And here also you want a relation between temperature and volume. Now what do? You differentiate this entire equation. Both volume and temperature are variable. If we differentiate, let's keep temperature as constant, T to the power 3, V to the power minus 1. If you differentiate, you'll be getting minus 1 into V to the power minus 1, you'll get V to the power minus 2. So let me keep here V to the power minus 2, you'll get minus 1 by V square. Next, keep V to the power minus 1 as it is. So it will be V to the power minus 1, it will be here and 3T square dt. And before that, one more thing, you should also mention here dV, that is what is required, plus 3T square dt divided by, here let me put here V, that is what is required, is equal to the constant differentiation 0. You are going to obtain this. Next thing you see, 3T square dt by V, let me put it here, 3T square dt by V is equal to minus, this will go here, it will become plus. So T cube dV by V square. See the terms that will be cancelled out clearly. V and this V cancelled out. T square will be cancelled out. You will be left with 3 times of dt is equal to T dV by V. You are going to obtain this. Now clearly you have to find out a relation in this way. You want dV by V dt. So dV by V dt you will be obtaining as, if we do, so 3 by T will be equal to dV by V dt. Hope that you have got the value of coefficient of volume expansion. dV by V dt, that is the coefficient of volume expansion. So dV by V dt, and that comes out to be 3 by T. That's a temperature dependent term, 3 by T. So let me put here gamma will come out to be 3 by T. That's the required result. Let's check with the given option. A 1 by T, incorrect. B 2 by T, incorrect. C 3 by T, that's the correct answer. D 4 by T, again incorrect response. So the correct answer will be 3 by T for this question. That is the coefficient of volume expansion is 3 by T. It's a temperature dependent term. Let's go ahead with the next question of the session. Next question of the class, question number 7. It's a more than one choice correct. That means more than one option can be correct in this question. 1 mole of an ideal gas in initial state A undergoes a cyclic process ABCA. You can see here this graph given here, the curve given here. A to B to C to A. It's a VT curve. Volume is on the y-axis and temperature on the x-axis. As shown in figure, its pressure is at A is P0. At A, you can see the pressure is P0 that is given. Choose the correct option from the given, from the following. Now, first option, internal energies at A and B are the same. Internal energies at A and B are the same. We know that internal energy is the function of temperature. Here you see A point is here, B point is here. Temperature is T0. So, since internal energy is a function of temperature, I am writing here U is directly proportional to temperature. Since temperature is same for both A and B, yes, internal energy at A and B will be same. So let me write down here, since TA is equal to TB, therefore UA will be equal to UB. That is, internal energy will be same for both A and B. So internal energy at B are the same. Yes, it is same. B, work done by the gas in process AB is P0 V0 ln4. Work done by the gas in the process AB. Let us evaluate the work done in the process AB. First of all, you see AB, what is happening? The temperature is constant. It's an isothermal process. So let me write down for A to B. For A to B, the process is isothermal. That is what we can identify. The process is isothermal while going from A to B. If it is isothermal, I have told you how to evaluate the value of work done. The work done comes out to be in an isothermal process. That is nRT ln, you see here nRT ln final volume divided by initial volume. This is what we can comment on the value of the work done, nRT ln final volume and initial volume. Now here you see it's a 1 mole of an ideal gas. So clearly N will be 1, R keep it as it is, temperature T will be T0, that is what we can say. And then you see final volume is 4V0, initial volume is V0. So final volume is 4V0, let me put it here. Final volume as 4V0 and initial volume as V0. So work done from A to B for an isothermal process, N1, R as it is, temperature T0, ln 4V0 divided by V0. That is RT0 ln 4. You are going to obtain this. Let us check with the given result that we are having. Work done we obtained for A to B. RT0 ln 4. Now let's go. Now RT is given as P0 V0. Now nRT is equal to PV. So here you see it's given that since we can write that nRT as P0 V0, the pressure at A is P0. The pressure at A is P0, so you can write that RT0 will be equal to P0 V0. So let me write down, since pressure at A is equal to P0 and the volume is also V0, so we can write that P0 V0 is equal to nRT, so N1 R T0. So RT0 you replace as P0 V0, you will be obtaining work done as equal to work done from A to B, that will be equal to RT0, substitute as P0 V0, P0 V0 ln 4. This is what you are going to obtain. And let's check with the option number B. Work done by the gas in process AB is P0 V0 ln 4. Yes, this also option is correct. Pressure at C is P0 by 4. Now pressure at C, it is asking what it is. Now first of all, from this curve in the question, it's not given that this curve, this straight line B to C is going and touching the origin. It's not mentioned. So pressure at C we cannot evaluate. We cannot evaluate because we don't know about the temperature, what's happening. So we cannot evaluate the value of pressure at C. So this cannot be, nothing can be commented on it because it's not given in the question. This line is passing through the origin. Temperature at C is T0 by 4. Again, that is also cannot be evaluated until and unless we comment on that this line is passing through origin. So we cannot comment on this. This will be incorrect. The correct option for this question will be A and B. Internal energies at A and B are the same. Work done by the gas in process AB is P naught V naught ln4. That is what we can say about this question. Hope you have obtained how JEE asked question in your advanced examination and how you have to judge which answer suits the best. You need not to take things on your own that this curve has to pass through origin and you're going to comment on the pressure and temperature, which you can't actually do. Let's go ahead with the next question of the class, question number 8. During the melting of a slab of ice at 273 Kelvin at atmospheric pressure, ice melts at 273 Kelvin. 273 Kelvin is equal to 0 degrees Celsius. First of all, 273 Kelvin is equal to 0 degrees Celsius. Ice melts at this temperature. Now what happens if ice melts? It's converting from solid to liquid. But initially as it melts, you must be thinking that volume expands. But the anomalous expansion of water, it will just opposite happens. Contrary to this, we find that volume decreases. So initially at 0 degrees Celsius, volume will decrease. That is what happens in the case of ice water system. Initially at 0 degrees Celsius, when ice converts into water, volume decreases. This is what we know about the ice water system. The volume is going to decrease. Now you see, when volume is going to decrease, it means the atmosphere is going to do some work on this system. Rather, the system is not going to do some work on the atmosphere. Let's go and find the given option. Positive work is done by the ice water system on the atmosphere. Since there is no expansion, the ice water system is not doing any work on the atmosphere. It is in fact getting contracted. Work is done on it. So this will be incorrect. You have to think logically. B, positive work is done on the ice water system by the atmosphere. Since it gets compressed, it gets contracted, then we'll be having that positive work is done on the ice water system by the atmosphere. Yes, positive work is done on the ice water system. The internal energy of the ice water increase. Actually, there's a thing that's missing. It increases. The given option, it increases. We need to check the internal energy of the ice water increases. First of all, now you see it's getting compressed. So what will happen? Let me write down here. We all know that dq is equal to du plus dw. Now what will be the value of du? Du is equal to dq minus dw. That is what we can actually comment. Now once again, what to do, take note till here. Let me write from the other end, take note till here. Okay, now let's talk about the change in heat energy and the work done. Now when ice melts, it's going to take heat energy from the atmosphere. When any system takes heat energy, that means the change in heat energy will be positive. This term will be positive. Now what about work done? Since work done, the work is done on the system, that means work done by the system will be negative. So you have to take dw as negative, as work is done on system. So you have to take in this work is done on system, so work done will be negative. So now if I put here, I'll be finding that du, this dq is already positive, and minus a minus work done. So we will be having this entire term as positive. That means internal energy increases. So let me write down, that means internal energy increases. This is what we can comment. So if internal energy increases, let's go and check the option. The internal energy of ice water increases. Yes, it increases. The internal energy of the ice water system decreases. No, it will not decrease, it will increase. So option number B and C are the right option for this question. Let's go ahead with the next question, and just let me wipe the board for you all. Next question. Hope you are enjoying and hope you are learning with each question. Question number 9. It's an integer type question. JEE Advanced can ask integer type question where if one integer will be correct between 0 to 9. So you have to choose which option you are getting, which integer you are actually getting for the answer for the question. A piece of ice, heat capacity 2100 joule per kg per degree Celsius. This is actually specific heat capacity. This is not only heat capacity, it's specific heat capacity. And latent heat 3.36 into 10 to power 5 joule per kg. Latent heat is also given 3.36 into 10 to power 5 joule per kg of mass m gram is at minus 5 degrees Celsius. At atmospheric pressure, it is given 420 joule of heat so that ice starts melting. So when you're giving heat energy, that means the amount of heat energy given, that is 420 joule. So Q is equal to 420 joule, that is what is given. So that the ice starts melting finally when the ice water system is in equilibrium. Now ice water system is in equilibrium, that can be only attained when the temperature is 0 degrees Celsius. So for at equilibrium, the temperature will be equal to 0 degrees Celsius. That is what we can comment. It is found that 1 gram of ice has melted. 1 gram of ice has melted, that is 1 gram will be converted into water. So this data is also important. Next thing, assuming there is no other heat exchange in the process, the value of m is. So you have taken m gram of ice. So first of all, you have to take m gram of ice from minus 5 degrees Celsius to 0 degrees Celsius. This is what is happening. So let me write down heat given is equal to heat taken by ice to convert to get raised in temperature from minus 5 degrees Celsius to 0 degrees Celsius. So you have to take m into specific heat capacity of ice. I am writing as, let me write this as C of ice multiplied with change in temperature, that is actually 5. Next thing, what is happening? 1 gram of ice is getting converted into water, that is what is given. It is found that 1 gram of ice has melted, it's converted into water. So plus, and ice when converted into water, you have to use m into L. So 1 gram of ice, so 1 into 10 to the power minus 3, that will be in kg, and latent heat of fusion of ice you have to use here. Let us put all the values. Heat given is 420 joules. So heat given 420 joules, mass m that we need to evaluate, and now see, it is asked as the given thing is in 1 gram. So you have to answer in grams what value of mass you have taken. So m into 10 to the power minus 3 you multiply, you will get the answer in grams. C of ice, that is given as 2100 joule per kg per degree Celsius. So put it here 2100 with proper SI units. Delta T, that is the change in temperature from minus 5 to 0, so that will be 5 plus 1 into 10 to the power minus 3 multiplied with LF, that is the latent heat of fusion of ice, that is given as 3.36 into 10 to the power 5 in standard units. So let me put here 3.36 into 10 to the power 5. So after solving this, only calculation part is left. We can easily solve this. After solving this, you will get m is equal to 8 grams. Only calculation part is left, that can be easily checked. You can easily solve this. You'll be finding that m is equal to 8 gram. So let's check what you have to do. You have to choose an integer. So you have to mark 8. You have to bubble the option carrying the digit 8. So in that way, you have to answer the integer type question. So I believe that's an easy question, not too tough. You have to only use the concept of calorimetry here, or you can use that heat given is equal to heat taken. Easy question. You have to only form the things and you have to actually mention what is happening and easily reach to the required result. Next thing, question number 10 of the day. Diatomic ideal gas is compressed adiabatically to 1/32 of its initial volume. If the initial temperature of the gas is Ti in Kelvin and the final temperature is ATI, the value of A is. We need to find out this. First of all, let me tell you for adiabatic process. For adiabatic process, we all know that PV power gamma equals to constant. This is what we know. And here we have pressure and volume. If we want a relation between volume and temperature, we should write P is equal to nRT by V. We can write this. So replacing this, and let me write down P equals to nRT by V multiplied with V to the power gamma, we can get this is equal to constant. N and R are constant, T you keep it as it is, we can write this as TV power gamma minus 1 is equal to constant. That is what we can actually comment. So what you do, take note till here and let me write at the other end, take note till here. After taking down this, we can use actually TV power gamma minus 1, and gamma for a diatomic gas, it's 1.4 or 7 by 5 you can use. So for diatomic gas, we can say gamma is equal to 7 by 5, that is equal to 1.4. Now, given that using a T initial, V initial power gamma minus 1 is equal to T final, V final power gamma minus 1. Now, given that temperature final is A into Ti, final temperature is A into Ti and initial temperature is Ti, that is what is given. And the volume reduces to 1 by 32 of its initial volume. So let me put here, we can write here volume final is 1 by 32 of its initial volume and temperature final is A into Ti. Let me put up all the values in terms of the initial values, you can find the value of A. So finally, using these two values and keeping it here, we can write that T initial, V initial power gamma minus 1 is equal to T final, that is A into Ti, multiplied with V final, that is Vi by 32 power gamma minus 1. Now, what you can do, you can actually cancel out some of the variables, Ti, you can cancel out. So after this, let me put up here, you want the value of A, Vi will be also cancelled out. So this will come out to be 32 will go here, you will get 32 multiplied with power gamma minus 1, 32 to the power gamma minus 1, you are going to obtain this. So because 32 is in the denominator, it will go here, you get 32 to the power gamma minus 1. So let me put up the value 32 and gamma minus 1 is 1.4 minus 1. Because 7 by 5 is 1.4, 1.4 minus 1 you get 0.4 and 32 can be written as 2 to the power 5. And this can be written as 1.4 minus 1 as 0.4. 5 into 0.4 you get 2, so 2 to the power 2 you will get this as 4. So finally the digit you have to encircle, that is 4 in this question. The value of A will be 4 for this question. Hope you have got what kind of question the JEE Advanced Examination actually seeks from you and what kind of concepts in detail you have to learn. So learn every chapter in detail, practice more and more questions so that you can understand how you can apply all those concepts in various kind of applications and you can understand that how different variety of questions can be framed. So for this question, the answer is for A is equal to 4, you have to encircle the digit 4 in your given OMR sheet. So this is all we have in this session of JEE Advanced exercise for this chapter. I'll meet you all with some more questions, with more discussion, with more concepts in the next class. Till the time, wishing you all the very best and thank you everyone for joining me.